All right, so this problem is very similar to a couple questions ago anyway. We've got spring scale measuring a force. I can't read that on the screen. It measures, A measures FA, and then B is going to measure FB. So this is FA, and then this is FB over here. Using a free body diagram, show the forces acting on the block. Rather than a free body diagram, I'm just going to show it here. So we have mg, then we have FB, and then exactly horizontally we have FA. So we know the horizontal, however much we went to the left, should equal the amount that we went to the right. And if this were on a grid, then we would actually count up those boxes just like we did previously. In the vertical direction, however much we go down should equal however much we go up for force B. They should cancel each other out. Now we're asked to derive expressions. Good. Deriving, we like that because it's relatively easy. We get to skip all the math. All right, so for FA and FB in terms of mg and theta. All right, so for this, we have horizontal forces in the x direction, so the net force in the x, and then we'll have the net force in the y direction. If we add both of these up as a normal vector, then we'll get whatever the resultant force is combined. But first, let's go ahead and do the horizontal forces. So we have the stuff that makes it go. Do we want the right to be positive and left to be negative? Normally that's what we do. So we'll do, it's going to be the horizontal component of FB. Uh-oh, Mr. Scopetis, it looks like you drew your triangle wrong. Well, I didn't draw it wrong, but I probably drew it different than you did. If you'll take a look, this angle theta is given from the vertical. So that's going to already be one of our components right there. So that way, there's our theta right there. So this tells us this is the opposite, and this is the adjacent side. And then FB is the hypotenuse. So the stuff that makes it go is going to be the opposite, and we have hypotenuse. So it's going to be FB sine theta minus the stuff holding it back, FA, equals 0. I'm going to erase that y component first so I can just fully solve this out and see if I can get any definitions from here. And I get FB sine theta equals FA. Wait a second! That's it? We've already done the first part. Now let's go ahead and figure out what is this FB equal to. So let's get to it. So the net force in the y direction. So now we're dealing with the adjacent side of the triangle. So adjacent, and we have the hypotenuse. So now in the vertical direction, if we're thinking of up as positive, then the stuff that makes it go is going to be cosine, FB cosine theta. And the stuff holding it back is going to be mg. It's not moving, so all of that equals 0. Okay, so when I add mg to each side, I have FB equals mg. Whoa. FB cosine theta equals mg. And then getting FB all by itself, I'll divide cosine theta from each side. And I find out that force B equals mg over cosine theta. Are we in our limits here? It says in terms of mg and theta. Mg theta. Cosine is fine because that's just the function that we're doing. Up here, we say FA equals FB sine theta. Okay, well now we know what FB is. So we have FB completely, but FA does not meet our requirements. So we're going to just substitute all of this junk right in there. And we're going to have FA equals mg over cosine theta times sine theta. All right, so here is where it would get tricky. If you don't know your pre-calc, if you don't know your trig identities. So when I rewrite this, I find that FA equals mg sine theta all over cosine theta. So if you know your trig identities, then you know sine over cosine is tangent. So then rewriting this, we get FA equals mg tan theta. And that is allowed. So that is simplified all the way, and it meets the terms that it's been given to us, mg and theta. Yes, this does too, but it's not simplified all the way. If it's a free response question, you're good. I wouldn't worry about, I wouldn't stress if you don't remember that sine over cosine is tangent. But if it's a multiple choice, which is more than likely what you're going to see here, then you do need to know sine theta over cosine theta equals tan theta. And it's okay to just put that fact into your brain if you don't have it yet. If you're dividing sine theta over cosine theta, it's just tan theta. That's it.